Hi there. Today I'm going to do a deep dive into the components of a FedRAMP compliant multi-cloud architecture. Whether you're building a new cloud environment from scratch or evaluating your existing architecture for compliance gaps, this walkthrough will help you understand what's required and why it matters. My name is Reed Rising and I am the Director of Engineering at Stratus Cyber, and we are specialists in secure, compliant cloud architectures. So what makes this video special? I'm not just listing architecture components. I'll explain why each piece matters and the benefits you'll gain. As we explore each component, I'll highlight the key FedRAMP controls that drive these architectural decisions. This is a practical, engineering-focused guide you need when building a compliant system. You'll learn which architectural patterns satisfy the more critical FedRAMP controls and how to avoid certain compliance pitfalls. One important note, FedRAMP has hundreds of individual controls across multiple control families. I won't be walking through each one as that would take hours. Instead, I'll highlight the more significant control mappings and compliance requirements as we explore each component. So here's what we'll cover in this video. First, I'll give you an overview of the multi-cloud architecture spanning AWS and Azure. Then I'll walk through the AWS organizational structure and explain why we use multiple accounts. I'll also demonstrate how Zero Trust Network Access is our preferred access solution. Next, we'll dive deep into each account type: the networking account, the shared services account, the security, logging, and workload accounts. And throughout, I'll map key components to specific FedRAMP controls. Finally, I'll discuss where infrastructure as code fits in. Now, as a quick compliance primer, for those new to FedRAMP, please search online for the FedRAMP Security Controls Baseline to find the full requirements. It's a complex document with controls organized into control families, which are groupings like access control, or AC, and configuration management, or CM. The complexity of these controls is exactly why we're translating it into practical architecture patterns today. And let's actually quickly go through some of the key technical control families here. So first up, we have AC, or access control. And as the name suggests, it controls who can access what. This drives our multi-account structure, which we'll discuss, role-based permissions, etc. The AU control family, the audit and accountability, this ensures you're logging everything that you can and can trace actions back to users. The CA control family is the assessment, authorization, and monitoring, and covers continuous monitoring requirements. So this drives our vulnerability scanning, our security assessments, and why we generate monthly POAMs, which is also something we'll touch on in this video. The CM control family, configuration management, concerns maintaining consistent, secure baselines across the environment, across your systems. CP, contingency planning, ensures you can recover from disasters. It drives our backup strategies, multi-region considerations, and why we test failover procedures. The IA control family verifies users are who they claim to be. This is why we implement things like multi-factor authentication, or MFA, or use strong authentication or identity tools like Microsoft Entra. The IR control family prepares you to handle security events. This drives our SIM implementation, automated alerting, and incident response runbooks. The RA family, risk assessment, identifies and addresses vulnerabilities. This is why we scan monthly, track all findings, and maintain that continuous monitoring rhythm. The SC control family, system and communications protection. This concerns protecting data in transit and at rest, and also drives our encryption requirements, network segmentation, and boundary protection. The SI control family, system and information integrity, ensures systems remain secure and uncompromised. This is why we implement things like file integrity monitoring, malware protection, and have vulnerability remediation timelines. Now, those are just brief summaries of those controls. There is a lot more to them. They go pretty deep, but that's just a quick high-level primer of them. All right, let's do the dive into this architecture and begin with the 30,000-foot view here. So as we can see here, this is truly a multi-cloud architecture. We're utilizing both AWS and Azure, as you can see in the bottom here. So why multi-cloud? Well, we're leveraging the best services from each provider. For AWS, we love the infrastructure capabilities of that cloud provider, and so that really is the bulk of the architecture. For Azure, we particularly love the identity and certain security tools within there, namely Entra, Microsoft Sentinel, and Defender for Servers. On the AWS side, we're using a multi-account structure organized into organizational units, or OUs. In the center here, we can see the security OU, and under which is the security account and log archive account. To the left, we have the infrastructure OU, and to the right, we have the workloads OU. Again, at the bottom we have Azure. It's just a few components. So the bulk of this really is AWS and this multi-account structure. So why did we choose this architecture, this multi-account structure within AWS? Here are the core benefits. First, blast radius containment. If one account is compromised, the impact stays limited to just that account. There are clear security boundaries. And so each account essentially operates in isolation. Second, role-based access control. For example, network engineers may only need access to the network account. Developers who really only touch the application, they may only need access to the workload account, which is where the application lives. This is least privilege in practice, and maps directly to FedRAMP controls AC5 for separation of duties and AC6 for least privilege. A third key benefit is clean cost allocation. While not a strict FedRAMP requirement, knowing the costs per function helps with resource management and budgeting, which is best practice, and the structure here, the multi-account structure, helps achieve that. So let me show you this second diagram to better illustrate the organizational structure that we're dealing with here. So first off, we have the security OU, which contains the security tools account and the log archive account. I'll be doing a deep dive into the different accounts later in this video. But I do want to point your attention to the child OUs that are under the security OU. We have a production and a staging or pre-production OU. So this is best practice to have basically a pre-production or staging environment, but it is also a FedRAMP control and requirement. Control CM3 of the configuration management family does require testing and validation of changes before implementation on operational systems. This structure provides clear separation between test and production environments, making it easy to demonstrate compliance with these testing requirements to auditors. Moving down, we have the infrastructure OU, which contains the networking and shared services accounts. Again, I'll be diving deeper into each of these AWS accounts later in this video. Further down, we have the workloads OU, which contain the workload accounts, and this is where your application stack would live. Lastly, we have the sandbox account, which is really just where development and testing is done, not necessarily required. Going back to the first diagram, let's go actually up here to the top right and take a look at the access solutions for this architecture. So as far as access goes, we do recommend using Zero Trust Network Access with either Cloudflare or Okta. If you are a CSP, a cloud service provider seeking moderate authorization, then we recommend Cloudflare. If you are pursuing high authorization, then we recommend Okta, as these are both FedRAMP authorized solutions. I should note that Cloudflare, although it's currently only moderate authorized, they are pursuing high authorization, and so that is in process. So why Zero Trust Network Access? Well, traditional VPNs create complexity when it comes to general practice or FedRAMP compliance, and there's some security concerns there as well. Whereas ZTNA really streamlines access. So let me explain the identity flow, as this is crucial for understanding our Zero Trust implementation. So pointing your attention back down to Microsoft Azure, we do have Entra, and that acts as our single source of truth for identity. Entra provides enterprise-grade identity management that's already FedRAMP authorized. There are a number of features in Entra that streamline operations required by FedRAMP, such as access reviews. So operations like those are essentially automated, helping reduce overhead. Additionally, Entra supports multi-factor authentication at the high assurance level. And so if you are pursuing high authorization, make sure that you're using an identity solution that supports MFA at the high level as well. And that is something we'll actually dive deeper into in a later video regarding multi-factor authentication and AAL3 compliance. So anyway, back to the identity flow. Users authenticate to Entra first, and then through SAML Federation, they can access either Identity Center in AWS, which gives access to the management console, or they can also access the Cloudflare or Okta ZTNA solution, also through SAML Federation. So we essentially have the platform level console access, and then we have the network level or infrastructure access. So here's the game changer with ZTNA. Once users authenticate at the edge with their Entra credentials, they get seamless access to internal resources. For SSH connections, for example, there's no re-authentication needed. The user authenticates at the edge, and they have straight direct access to the internal server. Why does this matter so much? There's two benefits here. First, simplified MFA implementation. One nuanced requirement is that if a separate set of credentials are used to gain access to your servers, then MFA is required at the server level as well. So for example, if I authenticate with my Entra credentials at the edge, but then I use an SSH key to access the server, MFA is then required both at the edge and at the server, and that can be a nightmare to implement at scale. With ZTNA and proper identity integration, we streamline this significantly. For SSH access, users maintain their Entra identity from edge to server with no re-authentication. Now for RDP access, that's a different story, as even with a ZTNA solution, you will be prompted to re-authenticate your Entra or your Windows credentials on the server. And if you are using Windows servers in your environment, you're most likely using Active Directory. So what we can do here is, in this situation, we can leverage AWS managed Active Directory to domain join your servers. And then what we can do is use something like Entra Connect Sync to essentially synchronize and pull the managed AD users into Entra. And then from then on, the identity flow is the exact same. So in this scenario, instead of using your Microsoft Entra native credentials throughout the entire authentication process, you're using your domain credentials throughout. So it's still one single set of credentials, no separate passwords to maintain, and no complex MFA at every server. Another benefit of using ZTNA is that it is very secure, much more secure than SSL VPN tunnels. Now, I do want to note, because this is an important FedRAMP requirement, is that according to a white paper that was released by FedRAMP in 2022, concerning subnetting and bastion hosts, it does state that bastion hosts are required in the environment. And so with this identity flow, what would happen is to access a server, such as a management server or a security tool server, it could be a vulnerability scanning solution. Essentially, to access your services within that management and security stack, you would first authenticate to the ZTNA solution, and then authenticate to a bastion host, and from there you can access your security tool. Alright, so now let's dive deep into the different AWS accounts. Let's first start off with the network account. So with the network account, this forms the backbone of our cloud network. AWS Transit Gateway is used as the central hub. It acts as the central hub, connecting all of the VPCs across the accounts. So why do we use Transit Gateway? Well, not only does it provide the centralized routing across all of these different accounts, this also supports FedRAMP Control SC7 for boundary protection, which is part of the System and Communications Protection Control family. Here we have Amazon Route 53 with DNSSEC enabled. DNSSEC is mandatory under Control SC20, and so we have to make sure that's in place. Relating to DNS, we also have the DNS firewall offered by AWS, and this adds an additional protection layer, although it is not necessarily required by FedRAMP. So within the network account, we do have the inspection VPC, which is where the AWS network firewall lives and conducts stateful traffic inspection. So stateful inspection tracks connection states and detects anomalies, which is essential for continuous monitoring requirements. AWS flow logs, you can see, is configured here, and so since we have VPCs in this environment, we have to ensure that flow logs is configured on every VPC. AWS flow logs capture all network traffic. This eventually all feeds into Microsoft Sentinel. And why is this crucial? Well, being able to log everything is crucial for incident response and forensics, and also provides auditing and accountability. One quick note here, if your application only handles layer 7 traffic, or the only traffic going inbound into your environment happens over layer 7, you might skip the network firewall. A web application firewall, or WAF, on your load balancer could suffice. Regardless, we include the network firewall here in our reference architecture. Going over to the right here, we can move on to the shared services account. And these are services used across the entire organization. We have AWS Identity Center, which again we've mentioned previously, but that receives the federated identities from Entra. Again, Entra acts as the single source of truth while enabling AWS native role management. We have directory service here in case we have a requirement, an operational requirement to have domain joined servers. Here we have AWS Systems Manager, and this provides centralized EC2 management. And this is actually a critical service. It enables consistent baseline configurations across all instances, which directly supports Control CM2 of the configuration management family. We can also streamline patch management with Systems Manager, which relates to the MA or Maintenance Control family. Additionally, with Systems Manager, we can also aggregate or pull software inventory across the servers. And this can be useful in satisfying software control or software whitelisting on your servers, which is also a control under configuration management. I do want to pause here and just say that there are other solutions that can provide similar services. For example, something like Ansible can be used. With something like Ansible, though, you would most likely self-host that on an EC2. And one of our primary design principles here is that we want to leverage platform managed services as much as possible. And so, yes, you could use a service like Ansible and self-host it, and that would give you your configuration management capabilities. But then, since you have that server in your environment, you're now responsible for patching it, for securing it, maintaining it. With FedRAMP, there are a whole host of requirements for compliance that all of a sudden become applicable once you have that server in your environment. With Systems Manager, since this is a platform service, we offload many of those compliance requirements to AWS, the cloud provider, thereby reducing overhead. All right, moving on, we have here the EC2 AMI or image builder. If you're building images through your pipelines, this is a good service to help maintain consistent compute images hardened against benchmarks such as STIG. STIG is the Security Technical Implementation Guide, and that is required by FedRAMP to harden your servers against it. If a STIG benchmark is not available on your system, for example, if you're using a specific Linux OS distribution that does not have an associated STIG, then you can use the CIS Center for Internet Security Hardening benchmark instead. Here in the center, we have the Amazon Elastic Container Registry, or Amazon ECR. And ECR provides container storage with built-in vulnerability scanning. This is a great service, as the integrated scanning helps meet continuous monitoring requirements without needing an additional tool. And specifically, this maps to control RA5 of the risk assessment control family. Here we have Certificate Manager, and so if you need to manage your certificates, SSL, TLS certificates that handle encryption in transit, you can do that here. But one money-saving tip, for internal hosts, FedRAMP generally accepts the usage of self-signed certificates, and so you may not necessarily need a certificate manager within your environment. Down here we have Secrets Manager, which is where you can store your credentials securely with automatic rotation. And we have AWS Backup, which is used to help satisfy certain controls such as CP9 of the Contingency Planning Control Family for system backup. Moving over to the Security OU, or Security Account. First off, we have AWS CloudTrail. So within the account, this is really all the heart of the security operations, and CloudTrail is really key to that. CloudTrail captures every API call across all accounts and provides that audit trail required by the AU control family. We also have Key Management Service and Certificate Manager. Again, if you need to manage your SSL certificates for data in transit, that relates to the SC control family. Or if you do need to store and manage keys, Key Management Service can be used for that as well. Our recommendation regarding keys, however, is to leverage platform managed keys as much as possible. Again, trying to offload the responsibility for compliance to the AWS provider. And so things like encrypting your EBS volumes on your EC2s or encrypting your databases on RDS, leverage platform managed keys as much as possible. We'll actually pivot over to the bottom here. We have Amazon GuardDuty, which is used to provide machine learning based threat detection. So this catches behavioral anomalies that signature-based systems might miss. This is not necessarily required by FedRAMP. If you have an endpoint protection solution like Defender already on your hosts, behavioral analysis can already be done at that level. But it may be best practice for you to still have this within your environment. AWS Firewall Manager. This is actually a single pane of glass where you can manage your different firewalls across all of your accounts. And so if you have your network firewall in your network account, your web application firewall or WAFs on your load balancers and different accounts, or even your DNS firewall, this can all be managed within here inside the Security Tools account. Security Hub. This aggregates all of the security findings from all the different accounts into a single view. And it's really key that we're able to centralize all of these operations of monitoring all of the other accounts into this single account. It prevents critical alerts from getting lost across all those other accounts. AWS Config Aggregator. This tracks all configuration changes at the AWS platform level. Again, this helps relates to certain compliance requirements for change management or configuration management. And up here we do have AWS IAM Access Analyzer, which helps identify overly permissive access. This is not necessarily required by FedRAMP, but may be best practice. So all of these services, AWS, Security Hub, GuardDuty, CloudTrail, etc., I do want to take a moment and say that these services do feed into Microsoft Sentinel eventually, which is the SIEM of our choice. Why do we use Sentinel? Well, it has superior correlation capabilities, and it's also FedRAMP High authorized. If we take a look at some of the earlier, or at least one of the earlier accounts that we viewed, so here we do have the primary components that we went over, but at the bottom we actually see these smaller components, which are the ones that we've discussed: Security Hub, GuardDuty, CloudTrail, etc. So I just want to note that within each of these accounts, we are monitoring them with those security tools. But it's only within the security tools account that we can actually manage those solutions. All right, so we do have one more kind of larger component to go through here. Within the security tools account, we have a VPC, which hosts several services. The first one we can discuss is Tenable Nessus. So Tenable Nessus is used for vulnerability scanning, and this is a critical requirement. Vulnerability scanning in general is. FedRAMP mandates authenticated scanning be done on your web application, on your operating systems, on your databases, on your containers. External scans are not enough, and this satisfies Control RA5. So Tenable Nessus is used to do that authenticated scanning either through credentials that are provided to it, or you can also install Tenable agents on your servers, which operate at that root level or privilege level. So Tenable Nessus will scan operating systems and databases, but for web applications, we do have a preferred tool, which is Invicti. So for web app scanning, Invicti is a great tool. It's enterprise-grade web application scanner. And so we like to use the best-in-class for different tools. So while Tenable does have a web application scanning feature, we want to make sure that we're using the best tool possible to ensure that we're securing the environment as much as we can. To the left of these tools, we do have the GRC or ITSM solution. Governance, risk compliance. ITSM is used for ticketing. So what do these tools do really? The two tools kind of work in tandem, and they cover a lot of different use cases. So ITSM is used for ticketing, change management. It's also maybe where you would submit incident tickets or service requests. Additionally, with this GRC tool, we can do certain compliance automation activities. So we can automatically pull in evidence from the cloud environment for FedRAMP compliance. And I won't go through this into detail at this moment, but I do want to mention that the FedRAMP program itself is trying to modernize. And if you research FedRAMP 20X, that's kind of what that whole effort is about. And so the GRC tool here is also prepared to align with the goals of FedRAMP 20X by satisfying key security indicators, or KSIs, which are metrics that are machine readable and evaluate the security of the environment. And so the effort really in the future is to automate things as much as possible, use as much machine readable data as much as possible. And so this tool helps position us for the future. All right, so this tool also can be used to create POAMs, which are plans of action and milestones. POAMs are essentially what you use to track and document findings. And so these findings can be from vulnerability scan results, they can be from configuration compliance results. They could also come from the audits and assessments that are conducted to assess your environment. If you receive findings from there, they can be turned into a POAM and tracked accordingly. And so this tool also is used to create those POAMs and track them through their life cycle from opening to remediation or closure. It's also where we generate monthly ConMon or continuous monitoring reports. One key activity within FedRAMP is that you have to generate monthly ConMon packages and deliver them to your sponsoring agency. And that's done every month. And so one of those artifacts is the POAM report. There are also other artifacts as well, which we can perhaps go through later in a different video in this series. But let's not forget, we also have agents, which are essential to the security of the servers that we have here. So we've already discussed Systems Manager. The SSM agent is what is used for Systems Manager to manage the servers within the environment. We also have CloudWatch, which provides additional monitoring capabilities. And then down here we have two Microsoft-related agents. The MDATP agent is the Microsoft Defender for Endpoint agent. This is what provides malware protection, integrity monitoring, or file integrity monitoring. And so those relate to the SI control family. We also have the Azure Monitor agent, and so this monitors all of the activity and logs data from the server to Microsoft Sentinel. And so that helps satisfy certain controls within the AU family. All right, with the security tools out of the way, we can move over to the log archive account. And you can see here, this looks a lot simpler, and that's intentional. So there's really no infrastructure being hosted here. This log archive account is intentionally separated. All it does is aggregate logs and data from all of the other accounts into this one account through a centralized S3 bucket. And so why do we separate it? Well, even if other accounts are compromised, this would also mean the logs are not compromised, right? So we want to make sure that the audit logs that we have are tamper-proof, and that's why we have additional security protections and really just isolate the logging component of this architecture. From the centralized S3 buckets, the logs that are aggregated into there are eventually ingested into Microsoft Sentinel. Again, Microsoft Sentinel is used for incident response. It provides great automated response capabilities, incident response runbooks or playbooks, and it's why we actually favor this as a SIEM over other solutions such as Splunk. It's also a platform service and relatively cost-effective. Microsoft Defender for servers, we've already discussed, that provides endpoint protection. This is where you would manage your Defender for endpoint agents installed on your servers. And of course, we've already gone through Microsoft Entra. Going into the workloads account. The workload account is what runs your actual application. And so this typically would come in the form of a 3-tier architecture. We have the application load balancer, which would be the front end of your application. Then we have the compute layer, which could be an EC2, or if you're containerized running microservice architectures, we could have containers hosted within Elastic Container Service or ECS. And that would be that middle layer. The third layer would be the database layer, and that would be a service like RDS. That's where your databases would be stored. Again, we want to leverage platform managed services as much as possible, and so our preference is that we stay away from using EC2s or self-hosting databases, but rather run containers on ECS, Fargate, or use for your database service like RDS. So within this VPC, I do want to also take another moment to expand on subnetting. So I did mention in 2022, FedRAMP did release that white paper on subnetting and bastion hosts. This is a mandatory requirement that you have proper network segmentation in the environment. This relates to the SC control family. If you do not have proper segmentation in your VPC that segregates your RDS, your databases, from your middle layer, your compute instances, and also segregated from your publicly available components, that is a high finding and can block authorization. All right, so just a little bit more on the application load balancer. This is where the WAF would be configured. This would provide layer 7 protection and defense against the OWASP top 10 attacks that network firewalls would miss. And with this architecture, really, only the load balancer would get a public IP. Everything else would be able to stay private. And this is great because it reduces the attack surface and forces all access through controlled points. Again, to internally access these private servers, you would go through ZTNA tunnels such as Cloudflare or Okta. So one great thing about this architecture is the built-in capability for scalability. We've got scalability magic here. So if you need a new application, or you have a new application stack and you want to get it FedRAMP authorized, you do not need to create an entire new environment with a security tools account, with a networking account, etc. All you have to do is spin up a new workload account with your new application stack and plug it right into this architecture. And so let's go back to this other diagram and we can kind of depict this in a better way. The network security tools, shared services, and log archive accounts, which we just went over, essentially operate as the hub of the hub and spoke architecture. And so again, if you want to deploy a new application, you have a new team of devs, whatever, all you have to do is deploy a new workload account into this architecture, and that new account would inherit the networking controls and configurations, the security tools monitoring, the shared services and logging capabilities that are already in place within this environment. Okay, so going back to the workload account here, I think that wraps things up. One last thing I do want to mention, these endpoints here on the VPC. So platform services like Systems Manager, like S3, like Key Management Service, they are public, they use public endpoints. And so what we've denoted here and illustrated is that we would want to use private endpoints. And the reason for that is you want to make sure that all of your network traffic is contained within your boundary. And so by being able to use a VPC endpoint for a service like Systems Manager, such as this SSM endpoint, that keeps things, all the traffic, private within your boundary, which is essential also for compliance and making sure that you don't get any unwanted questions or scrutiny during those audits. All right, so that about covers each of the different accounts. I do want to touch on a little bit more, or mention that this architecture is built using infrastructure as code, namely Terraform. And there are a lot of benefits to infrastructure as code, and benefits that relate to compliance requirements as well. One, we have version control, so every change is tracked in Git for complete audit trails. Two, there's consistency. The same code is deployed, identical architecture and systems are deployed every time. You can also implement peer review into your deployment pipeline, making sure that you eliminate or reduce human error. There's also rapid recovery here, and so if something needs to be redeployed, you can do that very quickly by executing the pipeline, and this is all within code. And all of this directly supports controls such as CM2 for baseline configuration. Through Terraform, you're able to prescribe the configurations of your systems, of what you're deploying. It also relates to CM3 of the configuration management family, which relates to change control. And so having that version control, being able to run that pipeline through a process where you have peer reviews and approvals, that all relates to change control processes and requirements that are mandated. All right, so with that, I do want to summarize the control families that are at play here. So let me map the architecture to bring it back to these key technical FedRAMP control families. And again, please note that there are more control families than this. These are just kind of the key ones that we're highlighting here. So with access control, we have the multi-account structure plus zero trust access. With AU, the audit accountability family, we have CloudTrail, we have flow logs, we have session logs, we have guard duty. All of those logging capabilities are aggregated across the accounts and ingested into Sentinel. Certain controls within the CA family, the assessment, authorization, and monitoring family, are satisfied via the vulnerability scanning tools such as Tenable, Nessus, and Invicti, and the GRC tool used for POEM management and continuous monitoring deliverables. The CM configuration management family, this would relate to Terraform and Systems Manager. So those are the solutions that we're using to make sure that we have established secure configuration baselines for the systems we're deploying, for the servers that we have in our environment. Additionally, Image Builder can be used to make sure you have a consistent secure image for your servers or containers. Additionally, we have the CP control family. Again, this relates to AWS backup, being able to have a backup to be able to restore to in case the availability of the system is at risk. The IA, identification and authentication family. Here we have strong authentication through Entra at the edge, and we have strong MFA, which can be also configured at the high assurance level. For incident response, we have automated response capabilities via Microsoft Sentinel with centralized operations. We also have the ITSM tool where you can log the lifecycle of incident response tickets and basically manage the lifecycle of the response within that tool to closure. For maintenance, this is quite simple. It's really just procedural, but this would relate to AWS Patch Manager, which is the patch management capability within Systems Manager, so streamline all of your patching operations. The RA family, risk assessment. Again, this also relates to vulnerability scanning tools such as Nessus and Invicti and AWS ECR. Then we have the SC control family, the system communications protection. This is where network segmentation comes into play. This is where your bastion hosts come into play. It's also where encryption is concerned, and so encryption for data in transit and for data at rest. Again, we want to use platform managed keys to encrypt, your EBS volumes, your RDS databases. Additionally, we have the SI control family, which is where Defender for Endpoints would be used to satisfy a number of those controls. And so Defender for Endpoints used for malware protection and also file integrity monitoring. I do want to touch a little bit more on the SC control family, particularly when it comes to encryption. FedRAMP requires a high standard of encryption called FIPS to be used, and this can be especially tricky to navigate. Your data in transit and data at rest must use FIPS cryptography, and it's not enough that a system is using FIPS encryption ciphers. They must also use a FIPS validated cryptographic module certified by NIST or the National Institute of Standards and Technology. So meeting these FIPS requirements can be difficult and can have an impact on significant design decisions, such as what operating system you can use in the environment. So now, FIPS is a whole nother deeper subject. We won't be diving into it more, but if you do have any questions, feel free to reach out to us. And that kind of wraps it up with the key technical control families. To summarize, this architecture delivers zero trust access through FedRAMP authorized solutions. We have single sign-on from the edge to the server. We do require Bastion hosts to be used to be able to access your security tools, your management stack. We also have one source of truth for identity, either through Entra or directory service. We also have strong security boundaries that are established via account separation. We also have centralized logging and monitoring. And of course, we have defense in depth. We have multiple layers of protection. We have firewalls. We have monitoring capabilities, logging capabilities. We have agents installed on infrastructure. And so FedRAMP, with all of these different control families, do require that defense in depth. With this architecture, we do also have scalability, essentially through account vending. And so we discussed that hub and spoke model, where all you need to do is deploy another workload account and plug it right into this architecture. And then we also discussed consistency through infrastructure as code. So thank you for joining this technical walkthrough. If you have any questions about specific components, control implementations, or need help building this architecture, feel free to reach out to us, StrataCyber, or our infrastructure partner, SMS. You can find me online on LinkedIn or visit stratacyber.com. Similarly, you can contact our infrastructure partner, SMS, at cloudwithsms.com. And remember, FedRAMP compliance is achievable when you have the right architecture. Thank you for watching.